welcome to the Rosetta demo. My name is Alison Vermeil.
And I'm Veronica Andrade.
I'm Daniel Frampton.
And I'm Joshua Bannon.
And I'm Matt Simon.
Rosetta is Google Translate for programming languages for developers just like you. It eases the process of learning new languages by translating a built-in function in a language you know into the closest equivalent and one that you don't. It does this by scraping official language docs and comparing them using machine learning with natural language processing to present you with the top 5 results sorted by relevance. V is going to take us through a demo next.
So this is the Rosetta interface. We're going to start off by selecting a language to translate from, so Ruby, and translate to JavaScript. We're going to select a method here, and it looks like we're going to select filter. We're going to hit the translate button, and you'll see on the left side here, we get the selected method with a description, syntax, and snippet. And on the right, you're going to see the top 5 results sorted by relevancy. You'll see that every card has a relevancy rating, has the name, description, syntax, and snippet as well. And you can select whether this card was helpful for you or not. Let's go on down and see what the This Was Helpful button does. If you see that Find Index has the relevancy rating of 84%, if we click This Was Helpful and we move up in the results list, you'll see that now it has a relevancy rating of 92%. And if we click This Was Not Helpful, you'll see that if we move down the list, you won't see it in the list anymore, and we get a new result card at the bottom. You can also do this from JavaScript to Ruby, but I'm going to go ahead and let Ali explain a little bit more about how this works.
Thanks, V. Let's talk about what's happening under the hood to make this work. We started by using a Python library, Beautiful Soup, to turn the raw HTML of the Ruby and JavaScript docs into workable objects. This required a fair amount of detective work to determine what type of headers and divs define each method title, description, snippet, and syntax. There was very little overlap in the layout of the 2 sets of docs, so they were considered one at a time. Once we had the code written to find the necessary information for all of the methods for each language, we wrote scripts to populate the methods table of our database.
And once we had the methods table populated, we used a natural language processing library called Spacey to compare a Ruby method with a JavaScript method. It came up with a relevancy rating of 0.001 to 1, which was then piped into our method results table. Once this table was populated with all of our comparisons of each method, we then piped this into our Flask web server, which is powered by Python as well. Our GraphQL server was Graphene, which is queried by Apollo client on the front end. React and Redux populated our global state, React components. Sass and JavaScript were also on the front end, providing both our CSS and also our standard script. Both front end and back end were tested, PyTest on the back end and Jest on the front end. Circle CI was available for our continuous integration, and we deployed using Heroku. I'm going to pass it off here to Daniel to discuss some of our challenges and our wins.
The first of our major challenges was that this was an ambitious project using several new technologies. A couple of solutions that helped us overcome this were collaboratively choosing our MVP goals through a feature prioritization exercise, which you can see depicted on the right, and through consulting our instructors to keep our project reasonably scoped. We also built time into the project to familiarize ourselves with new technologies when we were estimating the time to complete various chunks of functionality. And this led to a couple of wins. We met our MVP goals and completed one extension, the upvote and downvote functionality, in 2.5 weeks. Overall, we came away proud of our app's functionality and level of polish. Our second major challenge was that we were a fully remote team with 1 front-end student and 4 back-end students. Some solutions that helped us overcome this were establishing rigorous communication and workflow conventions early on as a team and sticking to them. We also used a thorough agile process, including ceremonies like story grooming, daily stand-ups, 3 to 4 day sprints, and team retros. We also established data contracts between the front end and back end, and were able to shift roles between the front end and back end as needs arose. And this led to our big win of having unanimous team satisfaction with our communication throughout the process. I'm going to pass this off to Matt, who's going to talk about future iterations of Rosetta.
Thanks, Daniel. Yeah, so one thing we would like to do in the future is restrict the amount of times that users can vote on a method. Right now, a user can vote as many times as they want, and since the user score is such a high weight on the relevancy rating, there is a high potential for abuse there. We would also like to allow users to submit their own code solutions. For example, there are a lot of Ruby methods that don't have a direct equivalent in JavaScript, so it would be nice if a user could submit their own code so that users can have more relevant results. We would also like to expand beyond array methods and add more languages besides Ruby and JavaScript. So yeah, that is our demo. Please let us know if you have any questions.